Thank you very much for the introduction and for everyone's coming to our presentation today. I'm Shusei Tomonaga. Our presentation today is about how to detect lateral movement using event log, and we will show a demo of our tools. First of all, let me introduce ourselves. My name is Shusei Tomonaga. I have been working at JPSAT for 5 years. My primary responsibility are to analyze malware and DFIR. We have been publishing analysis observation on our blogs. We also developed some tools which are useful for malware analysis. These are available on GitHub.
Okay, so hello everybody. Hello. Oh, thank you for the response. Okay, I'm Tomoaki Tani from JPSAT, and it's my first BSidesLV, and I'm very, very excited to be here with you today. And thanks for giving us an opportunity to having a presentation here, and thanks to attending, and thanks to all of the staff and the volunteer and BSidesLV. Okay, let's give up like this. Thank you. Okay, thanks. And Shusei and I belongs to the incident response group at JPSAT, and my primary responsibility is DFIR. Okay, so does everyone know JPSAT? Oh, thank you. Thank you very much. Yeah. Okay, I would like to speak a little bit about our group. Our group receives almost 10,000 incident reports every year and coordinate and cooperate with our partners to mitigate security incidents. Also, we handle 20 to 30 APD incidents per year and put in a lot of time and effort to them. And today's talks come from the experience we collected from DFIR, and I wish we would help your DFIR and your studies. Okay, before moving on to the main topic, I would like to talk about the current state of the incident response, especially in APD. Okay, as you know, when the incident happens, attackers intrude into the company's network and infect many hosts and servers with their malware using Windows default tools. In case the number of the infected hosts runs up to 100, then it takes months to reveal what happened there. Okay, so importance of the event log analysis. In APD case, event log analysis will be the key factor to identify the compromised host in the victim network. So why? Windows Active Directory records all the log-on histories to their event log, and we could chase the malicious activity from them. Many of the attackers try to spread the malware and execute it remotely with the AD authentications. Okay, so what's the trend of the malicious logon method? Nowadays, attackers use passive tickets when spreading the infection to other hosts. Passive ticket issues an unauthorized ticket that grants access to other hosts without additional authentication, and golden tickets is ticket granting tickets, and silver ticket is use service tickets. So, here's one question. Does Windows system record the passive ticket in the event log? No. Oh, thank you. The answer is no. So when the thank you for answering. Very nice. Yeah. So when the passive ticket the system records the same event log as the standard logon. And to detect the malicious logon from the event log, we need new analyzing techniques or new methods. So what's the best tool for event log analysis here? We would like to discuss. Yeah, great. Yeah, one option is Event Bureau could be the first option. Yeah, but we could use Event Bureau, but maybe everyone knows it's a viewer. It's not an analyzer, so yeah, it's very painful to analyze with. So the next option is to export event log to the text and file and use grep or AWK or sets. And yeah, it's much better than the viewer, but yeah, it's still painful if we have a large data size to analyze, and it's very difficult to analyze. And okay, how about theme? Yeah, SIM is very useful to search logs and yeah, to search statistical analysis. And the dashboard is very cool, so I love it, but yeah, it's not clear where to find the malicious logs. Okay, so the problem of the computational methods of analyzing event logs, there's 3 points. And first, it is difficult to investigate with the default tools. And second is the new techniques or new method is required to detect the pass the ticket from the event logs. And finally, it's not clear where to find malicious logs. So today's goal is to propose a method of analyzing Active Directory event log. Okay, in this presentation, we will introduce our approach to those challenges. So our approach is investigate malicious Windows log on by visualizing and analyzing event log. If we could support visualizing and analyzing event log with tools, it will make it easier to find out malicious activity such as pass the ticket PTT or pass the hash PTH. Okay, so here's a topic for today's presentation. First, we will talk about the event log visualization. And second, we will show the additional analysis of the event log using several algorithms and techniques. And third, we will introduce our tool, Logon Tracer. And finally, we would like to show the demonstration. Okay, from here, I would like to pass the mic to Shusei.
So after this slide, we will introduce how to visualize and analyze event log. How to visualizing event log. The event log has multiple events related to logon. The logon events contains account and host information, and analyze and visualize that information. In this slide, list of logon event IDs. These are about 20 logon events. For example, logon success is ID. The answer is no. It is possible to detect malicious logon without monitoring all logon event IDs. In our research, we know that it is important to monitor just 6 event IDs. The highlight event IDs are the events that we recommended to monitor. In addition to the success and failure of logon, NTLM and kernel-based authentication attempt is also important. The event log is not easy for analysts. Column name of event IDs are different for each event IDs, and not all the event ID has the same type of information associated of the ID. When analyzing event log, it is necessary to solve these problems. This figure is a simple pattern visualizing the event log. By visualizing, we aim to associate an account name and the host from the logon event IDs. Therefore, it is easy to check which account name used to log on to a host. This is an example of visualizing logon event ID based on the previous concept. The host and account ratio is 1:1. This is an example of malicious logon. We can easily find out that many hosts are logon using lateral movement. If malicious logon attempts to multiple host account from an account, the log will be like this. You have a good enough eyesight, you could find malicious logon from this figure. But most people will find it difficult to analyze this figure. From this result, we learned that visualization is good support for analyzing the event log, but not a perfect solution. We think that another approach is needed to analyzing the event log. Therefore, we thought about the next approach. It is difficult to analyze a lot of logs using visualization, but if we can automatically list suspicious account, analysis will be smoothly. So we propose a new method to automatically detect malicious logon. Next, let me introduce a method of automatically analysis. In order to create an automatic detection method, it is necessary to understand more about lateral movement. Through our experience, in many cases of incident response, we found that attacker normally conducted lateral movement in the following steps. This slide introduces the flow of APT incident. Attacker who infected the host with malware collect information on the host. Next, they collect information of other host and server within the network, and they spread the infection to other hosts. They will send confidential information using cloud service and so on. Last, they delete logs and created files. This is an example of lateral movement steps executed command by TIC's attacker. TIC is a cyber espionage group known to target Japanese organizations such as a government agency as well as those is biotechnology, electronics manufacturing, and industrial chemistry. The initial investigation starts with Who Am I command, then use Mimikatz to create a golden ticket. Internal recon use a ping command. After that, use net command to map a remote host. They executed the file to remote host with copy and AT command, and finally deleted the files. From our many experience of DFIR, there are three common features in lateral movement. First, attacker use not only attack tools but also Windows command and legitimate tools. Next, they use domain administrator account. Finally, they use stolen account repeatedly to Logon. Why attacker use domain administrator account? The reason for this is simple. It is possible to log on to all hosts and server using the domain administrator account. There are several patterns how an attacker take over domain administrator's account. The most common method is exploiting built-in administrator account. Many organizations use common password for administrator account to manage host. Therefore, if the attacker can steal one account at infected host, they can easily access all hosts and servers. The attacker uses lateral movement with one stolen password and account. As a result, a host that has been compromised by the attacker will be used for logon to many hosts with the same account. Logon to many hosts with one account is a suspicious activity. We apply this feature to automatic detection. We apply the common in the lateral movement introduced earlier to automatic analysis. Specifically, in this visualized event log, we propose a method to automatically detect user A. So, how can I automatically detect user A from this figure? There are several approaches to solve such tasks. We use network analysis to detect accounts that log on to many hosts. Network analysis is to analyze the property of a complex network in various fields. Network analysis has two metrics. Clustering is a task of grouping a set of objects in such a way that objects in the same group are more similar to each other than to those in other groups. We use another metric, centrality. In centrality and network analysis, centrality indicates the most important vertices within the graph. In other words, it is a method of clustering, calculating which node is connected to the most node. There are several algorithms to calculate centrality. The most famous algorithm is PageRank. PageRank is an algorithm used for Google search to rank websites in their search engine result. Idea of PageRank is as follows. Important web pages are sorted from many sites, so the number of links will be large. Web page linked from web pages with a large number of links have high importance. PageRank is also used for ranking other than web page. PageRank can be used for splitted graphs such as event log graph. The original PageRank algorithm was described by Brian and Page in several publications. We calculate centrality using this algorithm and found an issue. The PageRank for account logon is higher than only one host is connected. This issue is due to the algorithm. Even algorithms other than PageRank have this problem. So we investigate method to better calculate PageRank. We solve the issue using this method. Increase the rank of important account by changing the damping factor for each account. The PageRank theory holds that an imaginary internet user who is randomly clicking on the link will eventually stop clicking. The probability at any step that the person will continue in the damping factor. Various studies have tested differently, but it is generally assumed that the damping factor will be set around 0.85. So it has been proposed that the method to control the rank of the spam web page by adjusting the attenuation concentration. We also use a method to control the ranking of the account by controlling the damping factor. The PageRank that changes the damping factor value for each account is differentiated by the following formula. D is the damping factor of page A. And the next question is how to describe the damping factor. We dynamically calculate the damping factor from the following elements: account privilege, authentication type, anomaly detection of logon event log timeline, anomaly detection of transition of logon event logs. After this slide, we will introduce these elements. First element is account privilege. As I said earlier, the administrator account is used by the attacker. Therefore, it is better for the administrator account to rank higher. Second element is authentication type. If the attacker uses passhash, NTLM authentication is recorded. So if the account uses NTLM authentication for logon, the rank will be higher. Third element is anomaly detection of logon event log timeline. Anomaly detection by counting the number of logon event logs timeline. For example, a large number of logon failures may be brute force attack. We use Change Finder to anomaly detection. Change Finder is a time serial data change point detection algorithm that can detect change points in real time. Feature of page change finder is low computational complexity. Therefore, it is used for real-time anomaly detection. If change finder detects timeline anomaly, the rank will be higher. Finally, anomaly detection of state transition of logon event log. Windows Logon has 3 state transition: account not logon, logon attempt as logged on. If shift from not logon state to logon attempt and finally shift to logged on. If it is malicious logon, the state transition may become anomaly. In case of brute force attack or pass ticket, the state did not move to logon or logon attempt. We examined a method to detect anomaly in this state transition. So we propose a method to detect anomaly in state transition using machine learning. There are several machine learning algorithms to analyze state transitions. Recently, Recurrent neural network is mainstream in this field. However, recurrent neural network has a problem of large computational complexity. Therefore, we analyze the event log using hidden Markov model. The hidden Markov model is one of the most important machine learning models in speech and language processing. This model is a state transition of the past is hidden state, and the event is modeled from the output result of that state. This figure is an example of the hidden Markov model. For example, assume a person who repeats the three events: walk, shop, and clean. The event to be conducted will depend on the weather of the time. However, the weather itself is not disclosed. When you only know the conducted event, you can assume the current weather. This is how hidden Markov model works. We analyze the event log using hidden Markov model. Events are these Logon event IDs. And the hidden state are not Logon, Logon attempt, and Logon. Predict the state of the event ID timeline. Then hidden Markov model can detect that it does not move to stage 1 or 2. So this is an example of the analyzing the event log timeline with hidden Markov model. If normal Logon, it moves from stage 0 to 1 and finally moves to stage 2. But in the case of pass hash, it has not shifted to stage 1. If state transition anomaly is detected, the rank will be higher. We evaluate the page rank using these elements. As a result of evaluation, the method will be capable of detecting account using pass hash or pass ticket. By analyzing the event log, it is also possible to detect a suspicious Logon. However, there are cases which cannot be detected. Page rank with dynamic damping factor has problems. False positive, if the built-in administrator account is used for all host and server, the page rank of the account will be higher. False negative, if an attacker infected only one host, it is difficult to detect that activity. This is a future task.
Okay, thank you for introducing the core techniques and methods in Logon Tracer, Shusei. So from here, I would like to introduce our tool, Logon Tracer. Logon Tracer is a tool to investigate malicious logon by visualizing and analyzing Windows Active Directory event logs. It's a Python-based analyzing tool with web GUI. And we use Neo4j as a database, and we use Sitescape.js for visualizations. And it's open source software, so we developed on GitHub, and we released the first version last November, and we released the latest version 1.1 this August. Okay, Logon Tracer has 4 features. First is visualizing event logs. It makes it easier to understand what is happening in the victim's network. And second is display important account and hosts. And this is a very cool feature, and you can find suspicious accounts or hosts very quickly. And the third is additional event log search, and it's a preset search conditions for investigation, Active Directory event logs, and it accelerates your log analysis. And fourth is timeline. And you can make the timeline table very quickly in this tool, and this feature will help your analysis and reporting incidents. And this is a web GUI. I think it's very simple. Everyone, how do you think? Okay, I would like to introduce about the interface. So the upper side is the search navigation bar, and you could set the search conditions here. And the right side table shows the rank of the page rank with dynamic damping factor. And it's one of the most important part of this GUI. And the upper table here shows the suspicious account ranking, and the lower one shows the suspicious host ranking. So the higher rank is more suspicious here. And you can find malicious or suspicious or important accounts from this table. And the left side is additional event log search, like a preset for search conditions. You could use a drop-down menu to search account name matching to specific criteria. And here's a list of the additional event log search. These searches are very important when you investigate the Active Directory logs. In real case, I really do these investigations in sort search and DFIR. And here's the interface for the timeline table. And here it shows a summary of the event log and the number shows the count of the logs in each hour. And the colored cell shows the anomaly score. So if the darker color the cell has, it will be the cell has a higher anomaly score here. And this is a timeline graph. And this graph shows about the specific user. And you could check the transition of the events with the anomaly score. The red line shows the anomaly score here. Okay, let's move on to the demonstration from here. So we prepared a demo movie, and I would like to show how to use Logon Tracer. So movie starts. Okay. So first, how to start Logon Tracer. And yes, you can find how to start the web GUI. Where is it? Here, run. Start web application. So you can start web application with -R option. And now here is running on the local host with HTTP and ported 8080. So access to the from web browser, and here's the visualization mode. And if you click all user, you can find all the data here. And the red box here shows the graph visualization panel. So you could customize the visualization here. And the right side is, the top is search navigation bar, so you can set the search conditions, and here I'll explain it more detail later. And the right side is rank of the page rank with dynamic damping factor. And the left box here is graph options. Graph view option, so you could set the graph mode, or you could change the link values here. And here's a drop-down menu for search, and yeah, it's kind of the search preset search conditions here. Okay, from here I would like to show a little bit about the node details, so the icon meaning. The blue one is the standard account, and the red circle is system privilege account, and the green one is IP address or host. And the link detail is how to read the link. In this example, user administrator success to log on, host to the host, and yeah, very simple to read. So from here, and yeah, and you could check the account detail by clicking the node like this. Yeah, you can find the name, the privilege status, the security ID, and you can search it by the username. So click search, and you can find it. You can change the visualization, then you can drag the node. So you can clean up the panel. And yeah, you can find this account is very suspicious because it was used for, this account is used for several host logon attempts. And yeah, you could also search with navigation bar, click search. So yeah, you can show the account from here. And also you could add accounts here. For example, here you could account user, host, or IP address. So here it's adding IP address. And click search. So yeah, you can find out this here, and yeah, it looks very suspicious. And yeah, you could filter by event ID here. And if you only want to show 2 IDs, you can change like this. And you could also export data to CSV or JSON or images like PNG or JPEG. And here it's exporting PNG image, so just click and you can download it and you can get the file. So you can use it for reporting incidents here. And you could also search users from right side. For example, here we will click sysgadmin, the top one. Yes. So here, the top one is suspicious. So you can find with previous account using here. And also this host is, you could click host and you find it's suspicious like this. And from here, you could change the graph mode. The default is grid, but you could change coast and show all users. So it's yeah, you can find here something happening here, and here's a normal logon attempts. And you could also use a graph mode like circle, so you could show the graph like circle. And here you could add event values to links. So in this example, in the demonstration, it's adding count and auth names. So that's a little bit small, but you can find the authentication name and the user count here. Okay, and now checking the event ID again, and show the system privilege. Yeah, so ABD attacker wants target the system privilege account, so you can only check the system privilege account from this button. And also you could check the LTLM remote logons, only LTLM remote logons to check the passive hash, yeah. And you can check the domain which the accounts were belonging to. And this feature is useful when search if the Mimikatz is used, because the Mimikatz needs to enter the domain name, and sometimes attacker make a typo, so you can find the suspicious domain from this feature. And from here, it's showing the timetable, and you could click all to show the timeline summary. And yeah, and the color shows anomaly detection, so you can find something is happening on the 7th Tuesday or here, and you could check all. So yeah, it's very simple. It's very easy to check the timeline because it's colored. And also you could check, click the username to show the detail of the timeline. So you could find that the count in each event IDs. And here you could find the anomaly detection here like this. And also you could add search conditions from here, and you can compare accounts like this. So and you can find that the upper one has anomaly detection the 6th, and the lower one has the anomaly detection on 7th. And you can switch the timeline mode to the graph mode on the upper side switch, and you can search the specific user here, and yeah. Here you could find the high anomaly score in the middle, and this score is caused by the suspicious kill bill service ticket request event ID 4769 here. So you can detect that you can think that it's a possible over the past ticket here. Yeah, and you can find each event log count here. And yes, this feature makes it easy to analyze specific user. And click Alt to go back to the timeline summary. Yes, and yep, that's all for the demonstration. Okay, if you want to know more detail about the Logon Tracer, check it out our wiki on the GitHub. And this wiki you can find how to install Logon Tracer, or how to start with Docker, and how to use it from this QR code. Stop now. Okay. Time up. Oh.
Getting out of sight.